Today, we're diving into a group of bacteria that are, well, pretty much everywhere. They're all around us, and they're even inside of us. Now, most of the time, that's fine, but when things go wrong, they can become a massive public health challenge, a real medical emergency. So, let's get into it. And to really get a sense of what we're up against, I want to start with a question for you. What invisible threat, a threat that can be found in our own bodies and in our hospitals, is the single biggest cause of septic shock, a truly life-threatening condition? Just keep that question in the back of your mind as we go. The answer to that question? Well, it leads us straight to our invisible enemy, a whole class of bacteria known as gram-negative bacilli. And when I say they're everywhere, I mean literally everywhere. So, what are these things exactly? Well, gram-negative bacilli, or GNB for short, are this huge family of bacteria. That gram-negative part, by the way, it just refers to how they react to a certain lab stain. They don't hold the color, which gives scientists a clue about their cell wall. But here's what's so fascinating. Their dual nature. A lot of them are just hanging out in our gut, totally harmless, part of our normal microbiome. But if the conditions are right, they can flip a switch and become really dangerous pathogens. And that brings us right back to the question we started with. Yep, these bacteria are, in fact, the #1 cause of septic shock. And this is not some minor medical issue. The fact that they're becoming more and more resistant to antibiotics is turning this into a major public health crisis. To really understand the threat, we got to look at how they operate. You have to think of these bacteria as being equipped with a whole arsenal of tools that let them invade our bodies and cause disease. So let's take a look at their weapons. Think of all this as their toolkit for invasion. First up, they have what are called adhesins, which are like tiny grappling hooks that let them latch right onto our cells. Then a lot of them have a capsule, which works like a stealth cloak, hiding them from our immune system. They also use these things called cytophores. You can think of them as microscopic iron scavengers, stealing iron that our own bodies need to function. And then you've got the big guns, membrane proteins that can trigger a massive, overwhelming inflammatory response, and of course, toxins that can do direct damage to our tissues. And this just shows you how incredibly resilient they can be. Get this, some species, like Yersinia and Serratia, can actually multiply at 4 degrees Celsius. That's refrigerator temperature. And that creates a really serious risk in places you wouldn't even think of, like a contaminated blood transfusion. All right, so the battlefield for these infections can be anywhere, but the specific enemy we're up against really depends on the location. There's a huge difference between an infection you might pick up just living your life out in the community versus one you get in a hospital. Let's break this down. When you're out in the community, the usual suspect is E. coli, and a lot of times the infection starts in the urinary or digestive tract. But in the hospital, oh, that's a whole different ballgame. We see different, much tougher players like Klebsiella and Pseudomonas. And here's the really scary part. The rate of antibiotic resistance in these hospital-acquired infections is incredibly high. So why are hospitals such a hot spot? It really boils down to 3 main reasons. First, there's the widespread use of broad-spectrum antibiotics, which can kill off all the good bacteria and let the resistant ones take over. Second, there's always a risk of the bacteria spreading from one patient to another, often on the hands of staff. And finally, hospitals are full of the most vulnerable people, patients whose immune systems are already weak. You know, the infection itself is bad enough, but the real terrifying danger starts when the body's own response to that infection just spirals completely out of control. That's when an infection can escalate into sepsis. So what is sepsis, really? It's kind of a wild concept. The main problem isn't the infection itself, it's the body's overwhelming and life-threatening response to it. Basically, in its frantic attempt to fight off the bacteria, the immune system starts attacking and damaging the body's own tissues and organs. Because sepsis is such a massive medical emergency, doctors need a way to spot it, and spot it fast. They use this tool called the Quick SOFA score. Think of it like a simple 3-point checklist. They're looking for at least 2 of these signs. 1, fast breathing, so 22 or more breaths a minute. 2, low blood pressure. And 3, any kind of altered mental state. Spotting 2 of these is a huge red flag. Okay, so the alarm bells are ringing. Doctors suspect an infection, and they're worried about sepsis. What happens next? Well, the medical team launches a rapid-fire, systematic counterattack. It's a total race against time. The patient gets hospitalized immediately, often sent straight to the ICU if they're in shock. At the exact same time, blood is drawn for cultures to figure out which specific bacteria is causing the problem. All the while, doctors are looking for those signs of sepsis we just talked about and trying to figure out the context. Is this a bug from the community or a tough one from the hospital? That helps them choose the right antibiotic right away, while other tests, like scans, are used to find the source of the infection. Now, everything we've talked about so far is the response after an infection has already taken hold. But what if we could get ahead of it? The most powerful tool we have is always going to be prevention. So let's talk about how we stop these infections before they even start.
So, what does our defense look like? Well, for starters, it means treating any small, localized infection properly, so it never gets a chance to spread. In hospitals and clinics, it means being absolutely rigorous about keeping everything sterile. But there's one more strategy, a simple, incredibly powerful action that every single one of us can take.
So, what do you think it is? What is the single most powerful tool we all have to prevent the spread of these dangerous bacteria? It's that simple: hand washing. It is, without a doubt, one of the most critical lines of defense we have, both in our hospitals and just out in the world. It is the simplest and truly one of the most effective ways to break that chain of transmission. And that just leaves us with a final thought to chew on. In this age of evolving superbugs and incredibly complex medical technology, is it possible that our most basic habits, things as simple as washing our hands, will actually turn out to be our strongest, most reliable defense? Something to think about. Thanks for joining me for this explainer.